Have you ever wondered how deep sleep affects your muscle recovery at a molecular level? Today, we're diving into the science behind how deep sleep triggers rapid DNA repair in human muscle tissues. Our muscles constantly experience wear and tear, especially after physical activity. Understanding how our bodies repair this damage is key to maximizing performance and health. DNA damage in muscle cells, caused by metabolic stress and physical strain, must be quickly repaired to maintain muscle function and prevent premature aging. This is where sleep becomes critical. Deep sleep creates the optimal biological environment for this crucial repair process. Let's break down the three main factors involved: the deep sleep state itself, hormonal triggers, and specific cellular mechanisms. The first step is entering the deep sleep phase, also known as slow-wave sleep or SWS. This phase is characterized by the deepest level of unconsciousness and physiological rest. During SWS, muscle activity is minimized. This period of stillness and profound relaxation reduces the ongoing physical stress on muscle fibers, providing a break that is essential for repair initiation. Deep sleep significantly lowers heart rate, breathing, and core body temperature. This reduced metabolic activity lessens the production of reactive oxygen species, which are known to cause DNA damage, effectively slowing down further deterioration. Beyond just resting, deep sleep actively triggers the release of powerful chemical messengers that drive cellular regeneration. These are your body's internal repair crew. The most notable event is the peak secretion of human growth hormone, or HGH. The largest, most potent pulses of HGH occur precisely during slow-wave sleep. HGH is crucial for protein synthesis, which is the process of building and repairing muscle fibers. It ensures that the necessary materials are available for overall cellular maintenance, including DNA repair pathways. Now let's look inside the muscle cell to see the specific mechanisms that kick into action during deep sleep. Deep sleep enhances the activity of specialized DNA repair enzymes, such as nucleotide excision repair, which actively scan for and fix damaged DNA segments, ensuring genetic integrity. With the body's energy demands lowered during SWS, there is an increased availability of energy in the form of ATP to power these complex and energy-intensive DNA repair processes. Another key biological advantage of deep sleep is its impact on inflammation, which is closely linked to muscle damage. After intense exercise, muscles often experience inflammation. Deep sleep has powerful anti-inflammatory effects, helping to minimize this reaction and calm the system. By reducing the inflammatory response, the body is able to divert resources and cellular focus away from fighting swelling and pain and directly towards crucial restorative functions, including DNA repair. So deep sleep is not passive rest. It's an active, biologically engineered mechanism for cellular repair. In summary, deep sleep facilitates muscle DNA repair by creating a low-stress state, releasing HGH, and activating the necessary repair enzymes. Prioritizing deep sleep isn't just about feeling rested. It's essential for maintaining muscle integrity, optimizing physical performance, and promoting long-term health.